lunch. So I'll ask the next presentation if they could come forward now, please. This is Cyient, and I think we might have a replacement clicker. Good news. Okay, if you could come up onto the stage and give us your presentation. Thank you.
Afternoon, everyone. I'm Kiran. I'm a solutions consultant working for Cyient. Today I'm here along with my colleague Dan Fisher, flying from US. Especially, I requested him to come over here to present his experience in terms of the network migration, DOCSIS network migration, and share his experience or challenges what he faced during the migration. So, some of the very best cases he's going to present in the DOCSIS. So let's get into this straight away. And we know most of the people, we are aware that in the Nelson's law, it was predicted in 1983 that the bandwidth is going to, per annum it's going to increase 50%, or it doubles every 21 months. So of course it was adopted from Moore's law. Moore's law says the computing power, or computing capacity will double for every 18 months. So this is the target I'm setting up for my presentation. So based on this, actually, my further slides I'm going to go through. So what that means, the bandwidth predictions, bandwidth developments are predicted accordingly, bandwidth need, and especially the high-end users when they want to use the bandwidth. So the is maximum at average, or it was 50%. So based on that, let's look at the mega trends. What's actually making things are what things are driving the bandwidth. So everybody talked about this, and we know this, how the digital video is moving, especially the Netflix or Hulu or Apple TV or Apple videos. So some of the video trends are driving the bandwidth. The next one is the convergence between the mobile and fixed mobile and convergence are really feeling the bandwidth, or sometimes they're driving the bandwidth. The other trend is the apps, mobile apps. When the mobile convergence is happening from fixed to mobile, the mobile apps are really adding more value in terms of the bandwidth. They are demanding the more bandwidth, especially the augmented reality or virtual reality or artificial intelligence. These are some of the future drivers those are driving the bandwidth. The next one is the smart cities and smart homes. The automation in the home. Smart cities, especially the smart transportation, smart governance, smart e-governance, these things are driving the bandwidth need. And the next moment when we talk about smart homes, the next thing comes in mind is the IoT, Internet of Things. It's not only just IoT, Internet of everything, including the machine-to-machine, machine language. So these are some of the future drivers going to add more bandwidth need. Of course, finally, everything as service. Either it's cloud visualization of your equipment, visualization of your network, visualization of infrastructure, software as a service, or network as a service, or even desktop as a service. So everything is going to be virtualized. So what does these mega trends are saying? They need bandwidth. They are actually feeling the bandwidth need, bandwidth demand. They are driving the future. So having said that, so according to the major access technologies, what we have is three to four fixed access technologies, including your PON networks or G.fast, or DSL, XDSL, and DOCSIS. And when it comes to wireless, your satellite or your LTE, 4G or 5G, RF spectrum. Of course, Ethernet, although it's not a bandwidth technology, but at the end of the day, the Ethernet is playing a major role in terms of all these technologies. But the convergence, how it's moving is the wireline and wireless both are actually converged and they're merged so that the bandwidth can be pumped as per the end user demand. So today my interested topic is something on the DOCSIS, how the technology is moving, and then what actually the role we play in the DOCSIS. We are going to share that with you guys now. So let's have a look at this DOCSIS technology, how it's got evaluated. So it's 1997 back in days, and then DOCSIS 1 started with general basic data and using TDMA technology. Then it's more further to 2001, the advanced technology has been developed, that's 1.1. Although it's the same technology, but more security has been added into the 1.1 technology. Then further, 2002, back in 2002 again, DOCSIS 2.0 technology. It's asynchronous TDMA technology has been added, ATDMA technology, including SCDMA technology. And based on those frequency carriers, so the technology is moved from basic data video to voice-based, video-based applications supporting those applications. Also, the carriers started from 16 QAMs to 64 QAMs. So this is one of the major development that DOCSIS it's happened. The next one is the DOCSIS 3. This is the best technology. Actually, it started developing more and more advanced features, including the security, including the upstream enhancements and downstream enhancements, and then more QAM channel support, something like that. And then finally, the DOCSIS 3.1, we have seen that recently it's been announced in 2013, and it has started adding more, especially the 4K video, 8K video, Ultra HD videos, supporting the video content. So the DOCSIS 3.1 has been added. So what Nelson Lass says, Nelson Lass it's predicted that the bandwidth is going to grow. So based on that, the bandwidth, so what we are defining is the bandwidth is going one side, the other side, it has to be like synchronous bandwidth, either your downstream or your upstream. Both the streams should be synchronous because the demand for synchronous applications are moving very fast. So we recommend that the synchronous applications, synchronous bandwidth is going to go, according to the Nelson Law, is going to grow. And at the same time, the recommendation is something like you have to utilize your existing infrastructure, either into your layer 1 infrastructure or your layer 2 infrastructure. So you have to reutilize it, you will be able to reutilize that infrastructure. Having said that, let's look at the next development in DOCSIS, is the DOCSIS full duplex DOCSIS. That's creating a multi-giga bandwidths, multi-giga Ethernet bandwidths, multi-giga cable networks. So it actually started announced in 2007, recently, last month by Cable Labs. So it uses the full spectrum of your downstream, upstream, slowly moving from small QAMs to bigger QAMs, then adding more bandwidth. So it basically has four main key pillars or key intents, so that the bandwidth can be focused more or can be symmetrically given in up and down streams. So the Nelson's law now is going to change the way that it's symmetrical and up and down streams are going to match, and the symmetrical bandwidths are going to drive in the future. So this is what the prediction is going to happen. So DOCSIS 3 actually 3.1 symmetrical services are now redefining this Nelson's law. So the next another development in DOCSIS 3.1 is the remote PHY devices, where you move your physical capacity to deeper into the network, where so that the gigabit digital media can be utilized from your CMTSs, CCAPs, then making some of the functions visualized in the remote PHY devices. So next one is the deep fiber. Deep fiber is something actually, the other side, the fiber is going into fiber to the home, fiber to the premises technology. So cable industry started utilizing the fiber. So wherever the green fields are going, the deep fiber is getting into that. Deep fiber is actually avoiding the amplification of the cable networks, which is a major concern in the cable networks, so that the node plus 1 or node plus zeros are possible, so that the more bandwidth can be given to the end user, depends on the demand. So it's not only just the deep fiber, the other technology, major competing technology like EPON, Ethernet PON, or Gigabit PON, GPONs are actually beating the world of internet. So the cable technology started moving towards this, so that still you don't lose your RF spectrum, you don't lose your original RF, but still the GPON or EPON ONUs can be provisioned using the RF spectrum, so that still the cable technology, DOCSIS technology, can be given forward to the user. So the trend now, so far the trend is something like DOCSIS 1, 2, 3, 3.1, then modular CMTSs, CCAPs, and integrated CAPs, converged access platforms, remote PHY, fiber deep, and DOCSIS protocol over Ethernet or GPON. So this is a trend actually, so far we have seen as we speak, it's happening. But what is the future? Future is going to be full duplex DOCSIS, then DOCSIS for extended reach. The frequency extended reach is something that is going to go deeper into the network. Then virtualized CCAPs, virtualized orchestration. So CCAPs are going to be virtualized using SDN or VFN functionalities. Then even virtualized CPs is something that's already happening at the moment. But if you see the virtualized CP so far, it's not properly deployed on the field. So this is the future is going to happen. And then ultimately the final stage is going to be infinite DOCSIS, where you have the entire digital media till your tap, then you have your fiber, your still the cable is going to the end user. Sometimes even we sometimes it gives a kind of impression to us that your fiber is directly getting into the cable modem, that you still have your RF spectrum, the same flavor you are using the spectrum. So that way we are seeing the future is going to happen this way. So the focus areas in the entire the technologies movement, how they are developing, the focus areas are two areas. One is the network upgradation. Network upgradation is moving to a higher bandwidth, moving to the higher networks, higher areas is one greatest challenge for the MSOs. And the second area is, it's not only just, once you move the network, your job is done. The second area is something, operate, maintain, and further manage the network. How do you manage the network to ensure that your customer experience is really enriching? So these two areas, having said that, these two areas, the focus areas in DOCSIS network migration. So we will see the basically the readiness of the DOCSIS network migration, how it's happening. So we need to the operators actually need to see the spectrum is really available, or it can be freed up, the back your edge to core capacity is going to support you when you want to move further. At the same time, your readiness of the network, CCAP, CMs. So far, what we have seen is DOCSIS 1 still 1.1. CMs are still available, CMTs are still available in the network. So if you want to move the network to DOCSIS 3.1, 3.0, whether those are going to support for your network, or what is the network readiness is there. So that's one of the challenge we need to look into this. And second area is the compatibility, interoperability or compatibility of the network. So you have multi-vendor equipment deployed in the network, but how the network is getting compatible with the different things, and merging to the upgraded technologies. That's the next area the operators, the MSOs need to look in when they try to migrate the network. The third area is the skill set. We are seeing this DOCSIS or the cable technology is a limited area of knowledge. We see that, and how do we get the knowledge wherever we need? So that is another key challenge. So these three key areas, what we see is the major challenges for the network operations. Of course, there are other challenges as well. So whenever it comes to the operations, it's very simple. The challenges are very quickly easy to understand. Those are operation challenges, or your administration challenges, or your management challenges. When it comes to our operations, how do you operate the network? How do you manage your customer experience, or how do you ensure the quality of service is properly managed in terms of the operation challenges? So having said that these two challenges, what exactly the role we are playing, or how we are helping the operators, is like we have a plan, build, operate offerings, so through entire DOCSIS network migrations. So when whether you want to migrate the network, or you want to operate the network, so plan, build, run services are the solutions what we deploy for the MSOs. So we take the key pillars of the DOCSIS network migration. So that's deep fiber. Everyone is talking about the deep fiber. Deep fiber is the one which is going to drive the DOCSIS further. Having said that, deep fiber is going to make. So how do we enable the deep fiber? We have redesigned or re-optimized the services or the solutions where we utilize these things and then start driving the pillar of the deep fiber network. So we see that the driver is something like N+0 or N+1 architecture, so that your fiber is more the digital media, or your digital IP network is given to the customer. The next key pillar what we see is a multi-gigabit convergence. It's happening between the wireless and wireline and RF spectrum moving on the fixed line. So the second area, how do we help the operators? We help the operators, MSOs on the CMTS or CCAP network applications, our equipment upgradations, our network migration moving from 3.0 to 3.1. So different areas we focus here. The driver for us is the convergence between the RF and fixed networks and the visualized CCAPs. We have SDN, visualized network function related solutions. Those solutions we leverage to drive this multi-gigabit convergence. The third area is high capacity low networks, where the OEM comes operate, administration, and maintenance. This is the third area where we see that we have some solutions where we deploy the solutions, we virtualize sometimes, and we automate the network management configurations or firmware upgradations, software. So utilizing those things, we see that the technologies are properly migrated or managed very well in the future. These are the three key areas we help operators in terms of the DOCSIS network migrations. So having said that, I would like to hand over my presentation to my colleague, where he wants to share the real-time experiences and some challenges. Thank you.
Hello everyone, I'll try and make this quick. I'm sure everybody's hungry. Let's see if I can get this working here. I'm just gonna sort of go over a little bit about what we represent. I know a lot of everybody's been talking today about all of the different things that are happening in cable and how things are gonna look to improve and how it's gonna get better. But I don't know how much you guys really think about maintaining that and how much work goes into actually fixing it or keeping it operational. And I know somebody had said earlier about, when we're on a customer premise, it might be 1-2 pieces, but then change it up, you might have 14 times that. So that's 14 times the amount of actual equipment you need to either manage or work with based on event management or trying to maintain it and make it run faster, better, stay operational, all sorts of those. So the customer I'm going to sort of talk about today for everyone is now averaging about 1.1 million Wi-Fi hotspots in the US. That might not seem about that many, but at the time that we had done the implementation, it was about 11 to 14,000. It was like a dry run, seeing if they could do the Wi-Fi hotspots for phone service and things. But the other types of equipment that we were working with, of course, would have been, the RF gateways, the only like 300 plus CMTSs, and maybe only like 38K cable modems, and some other servers and stuff thrown in there. But once you start factoring in, you're at 50,000 plus devices. How many element managers do you have? What's going on with your entire network? You can have mayhem at times, but what do you do? So I'm just going to give you a little scenario here. We have just this cable company comes up to us and says, hey, we know we have a lot of element managers, could be probes, you're getting SNMP alerts, you're getting all sorts of stuff. And we want to monitor our video service. We have a lot of wants, and there's also a lot of needs tied into that too. We have our network operations center. You got to have some place that's going to monitor all this stuff and take care of it. You can't just deploy it out there in the field and go, all right, we're good to go, guys. Because they got to look at all these event management systems. I mean, you're going to have Eris out there, you're going to have a Cisco Man, you're going to have all sorts of stuff. And some people don't know how to run it, so you got to do the training, you got to get them certified to work in the NOC, you got to have security, you got to have all sorts of stuff, and it gets pricey. But a few more things here. Of course, the inability to catch and track and monitor outages. So how do you? We have an outage in Virginia that's taken out 30,000 customers, but we have no way to track it. We just know it exists. So we put it in a ticketing system, and now we have a ticket. Well, how do we know all of the things that relate to that ticket? So there's a lot of things they were lacking that we try to assist with. And then, of course, the lack of visibility into the outage footprint. So, all right, so we know we have a big outage in Virginia. We have a lot of people calling us, but how many people are actually affected? And then, that could pertain to either fiber issues where something got cut, somebody dug somewhere they shouldn't have, and they should have called, I'm from Pennsylvania, called 411, whatever. But then you have the issue where you need to upgrade firmware in OS because, hey, we're moving from DOCSIS 3 to DOCSIS 3.1. Is our equipment compatible? Can we just do an upgrade? Can we push it out? I know I get phone calls all the time saying, hey, your service is going to be affected between 1 o'clock and 2 a.m. Well, I'm an engineer, I'm working all the time. We have stuff going on all the time, so that does affect me, but at least I'm being notified about it. So the main problem that we came down the line with was the lack of correlation between all the event monitoring systems. So you have, like I said before, you have Eris, could be Calix equipment, you could have your, if you have a multi-provider, you could be doing video on demand, all sorts of different element managers. Well, they're spread and siloed all over the place. So, then you have the NOC complaining saying, hey, we don't have dashboards for this, wish we had this, wish we had that. And then, we have a whole bunch of CMTSs, say the UBRs, and we have a big outage, we lose a CMTS, how many people are affected? These are real easy questions that people come up with. They're not somebody saying, oh, I have a degree in, whatever, and I think we should, monitor this and do this. These are people that deal with this stuff every day. So you gotta listen to these people. I mean, they're what keep you alive. They're what run your networks. I know you guys are trying to think of ways to put it in, but somebody's gotta maintain it. And of course, you have your DOCSIS 2.3 stuff we come up with where they know they have so many people online, but how many people do they have in that area that are offline? Are they offline for a reason? What's your upstream versus downstream? Is it 100% utilized? Do I even have any availability on it? Does it need upgrading? So you have, just trying to get across to you guys what all has been, thrown at this customer for quite some time. And of course, what we end up seeing is it's just a whole bunch of siloed issues. Nobody's talking to each other, you have nobody working with each other, and there's no direction or resolution in sight. So we come up with, now it does vary per customer, of course. I'm not trying to sell anything here, I'm just saying, monitoring is key. You don't monitor, you don't see anything, you don't know what's going on. You can't rely on phone calls anymore. That's a reaction. You need to be proactive in this environment, which is what everybody's doing here today. You gotta be proactive, say, this is where we're going, guys, this is what we gotta do. So that's what you gotta try and figure out for your monitoring solutions. So we come up with some standard and say, all right, well, wherever you have markets that are over 75% overutilized, what's your CM counts, and do you have abusers? Do you have anybody that's offending, like your SLAs? You need to think about that. You can't just let them sit there and grind up 30 megabytes a second all day long for weeks when they really shouldn't be doing that, because you have SLAs that say you can only use so much throughout a day. And I know everybody's going to be angry with me at that one because you should be able to use your service that you want all the time. Well, yeah, that's great, but it's written in contracts left and right of how you're allowed to use the system, and you got to think about it, because when the reports get ran and you come up on the list that you're serving some torrent site that's feeding illegal data, now, well, maybe we should take care of them. Maybe we should do this, do that. So it's just something you got to think about. This is just a high-level breakdown of one of the architectural components. So I'm not going to even attempt to work with this clicker, so we'll just sort of go over the top solution, of course, is where your NOC guys would sit. They have the dashboards all at hand to them. They can do all the different tools they need to drill down into it, to check the customer premise equipment. They can do whatever they need to make sure it's good to go. The first yellow tier down is where all of your element managers get migrated into it. Now, when I say element managers, you could have 15, 20 different type of equipment out there. They don't all talk to each other. You don't have, Calix talking to the Eris, and then you have, all sorts of stuff working. It just doesn't work like that. You have different equipment, different manufacturers. It's just the way it is. Then you have your aggregation layer in the cream color, whatever you want to call in the middle there, where everything just comes together. That's where all of your probes, all of your stuff that's being gathered from all of your element managers to further roll up. And then even lower than that, you have your actual different networks. All of that information has to come from somewhere. So I know the gentleman before was saying about how you would have all of your different networks laid out. Well, this customer had one that was a video network, of course, and then you have one that might be cellular. You might have one that's your totally related to your GPON. You might have your CMTSs and everything else. But the thing is, the more you can segregate and categorize these networks, the easier it is to maintain and work with. And that's how we ended up taking all of these different markets, which at the very bottom there, we have the different markets across where people are able to discern we have an issue in this market or an issue in that market. And then that's how it does the roll up to see where the region is actually affected. So here's some of the solutions and the benefits, of course. So we take the EMSs, we correlate them all together. You now are going from, I don't know where this error is, or I don't know where we're actually affected, to actually having where this issue is. Who's affected? How many people are affected? Is it breaking an SLA? You have cause and effect. That's one thing that a lot of people need to work with a little bit more, is you have this, let's say UBR goes down, that's a cause. You know, what does it affect? It affects this region, it affects these people. So we work with equipment and we work with software that does those RCAs. So it automatically correlates everything for you. Then of course you have your impacts and escalations. Try to speed up for you. Of course your utilization percents, like I had said earlier, the past active cable modems versus that are active today. Did we have an outage? Is something going on? So you now are able to see that based on migrating and correlating all of the element manager systems together and writing just simple rules to say these equipment belong in the same, CPE. So this goes down, that goes down, we know everything works. So, but what are actual the benefits for this? So you now get into, let's say you were upgrading CMTS, or I'm sorry, your firmware from 3.0 to 3.1. Does it work? Do you have equipment that checks that? I mean, I'm sure you're relying on the guys that are running your modems to say, yeah, your software is completely compatible. Well, now you got to work with them to go through and do the upgrade, push it out, make sure everything works at a certain time. And it's, did you think about you got to hire these people to do this? You can't just say, put the equipment in and we're good to go. It's a lot of effort involved in trying to not only deploy the equipment, get it there and functioning, but maintain it. Thank you.
Thanks, Dan. So we would like to conclude our presentation. We say that change is vital. Definitely the change is happening. The network is moving to upgrade. But however, because the network is going, quality of service, quality of experience, both are two different phases. They need to improve. The MSOs are after these two areas. But we need to see whether the quality of service, quality of experience is really needs to enhance or needs to be there. So the operators should look into that, whether they need to really make things happen before doing the work. They have to think twice, do the work once. So that's what we say. They have to adopt the Carpenter or Taylor rules so that they can ensure that the network operations are happening properly. So.
Need the virtual clickers.
Yeah. So anyway, so we'd like to conclude this slide. So thank you very much.
Okay, thank you, Kiran and Daniel. Appreciate running through that quickly. Our final speaker